Helicopters are amazing machines. Like giant metal dragonflies, they can fly in any direction. Up, down, sideways, even hover in place. It's this freedom that makes them perfect for rescues. I've seen helicopters pluck climbers from mountainsides and survivors from raging floods. Real heroes, those pilots. But even these mechanical marvels have their limits. You ever wonder why helicopters can't reach the top of Everest? Helicopter rotors are basically long, thin wings spinning really fast. These rotors are the lifeline of the helicopter, allowing it to hover, move in any direction, and perform complex maneuvers that fixed-wing aircraft cannot. The science behind these spinning blades is fascinating and intricate. They create lift by deflecting air downwards. This downward deflection of air is what pushes the helicopter upwards, counteracting the force of gravity. The faster the blades spin, the more air they can push down, and the more lift they generate. More air deflected equals more lift. Simple, right? But there's more to it. The angle at which the blades cut through the air, known as the pitch, also plays a crucial role. By adjusting the pitch, pilots can control the amount of lift generated, allowing for precise control of the helicopter's altitude and movement. But here's the catch: air density. Air density is a measure of how many air molecules are packed into a given volume. It's a critical factor in flight because the more air molecules there are, the more lift the rotors can generate. As altitude increases, air pressure drops. This drop in pressure means fewer air molecules are available to be pushed down by the rotor blades. The air molecules spread out, becoming less dense. At higher altitudes, the air is thinner, which means there are fewer molecules for the rotors to interact with. At the top of Everest, the air is so thin, it's like trying to fly in a near vacuum. The lack of air molecules makes it extremely challenging for helicopters to generate the necessary lift. Rotors struggle to generate enough lift, making controlled flight almost impossible. Pilots must be highly skilled and understand the limitations of their aircraft when flying at such extreme altitudes. The science of the spin is not just about the mechanics of the rotor blades, but also about understanding the environment in which they operate. Mount Everest is over 29,000 feet high. This towering giant, the highest point on Earth, stands as a testament to the incredible forces of nature. Its peak pierces the sky, reaching into the stratosphere where the air is thin and the environment is harsh. That's higher than most planes fly. Commercial airplanes typically cruise at altitudes between 30 to 40,000 feet, but they rely on pressurized cabins and advanced technology to keep passengers safe and comfortable. Without these innovations, survival at such heights would be impossible. At that altitude, the air is so thin that humans can barely survive, let alone machines. The oxygen levels are so low that climbers need supplemental oxygen just to breathe. The human body struggles to function, and every step feels like a monumental effort. Engines need oxygen to burn fuel efficiently. In the thin air of high altitudes, there simply isn't enough oxygen to support the combustion process. This means that engines, whether in airplanes or helicopters, can't generate the same amount of power they would at lower altitudes. Helicopter engines, even powerful ones, lose power in the thin air. The reduced oxygen levels mean that the engines can't produce the necessary thrust to keep the helicopter aloft. This is a significant problem for any aircraft attempting to operate at extreme altitudes. This lack of power, combined with the reduced lift from the rotors, creates a perfect storm of aerodynamic challenges. The thin air not only affects the engines but also the rotor blades, which struggle to generate enough lift to keep the helicopter stable and in control. It's not just difficult to fly a helicopter to Everest summit, it's currently impossible. The extreme weather conditions, combined with the thin air and the technical limitations of current helicopter technology, make it an insurmountable challenge. Pilots and engineers continue to push the boundaries, but for now, the summit of Everest remains out of reach for helicopters. While reaching Everest's peak remains out of reach, engineers have developed helicopters capable of flying at incredibly high altitudes. These aren't your average choppers. They have more powerful engines, specially designed rotor blades for thinner air, and lighter weight materials. Some even use supplemental oxygen systems to boost engine performance. These adaptations come at a cost, both financially and in terms of payload capacity. Even with limitations, helicopters achieve the near impossible in high-altitude rescues. Take, for example, a daring rescue on Annapurna 1, one of the world's deadliest mountains. A climber was stranded at over 24,000 feet. The pilot, pushing his machine and skills to the limit, managed to land on a tiny, precarious ledge and evacuate the climber. This incredible feat highlights both the potential and the inherent risks of high-altitude helicopter operations. High-altitude flying is not for the faint of heart. The margins for error are razor-thin. The air is thinner, reducing pilot reaction time and aircraft performance. Strong winds and unpredictable mountain weather add to the danger. Then there's the risk of altitude sickness, even for the crew. One wrong decision, one mechanical failure can be catastrophic at those heights. Building and maintaining helicopters capable of extreme altitudes is expensive. Lightweight materials, powerful engines, specialized equipment, it all adds up. Then there's the cost of training pilots to fly in these demanding environments. It takes a special breed of pilot, cool under pressure with nerves of steel to handle these missions. Even with all our technological advancements, some places remain off-limits to helicopters. Deep within mountain ranges, where air currents are unpredictable and landing zones non-existent, the risks outweigh the benefits. In these areas, traditional climbing and trekking remain the only options for exploration and rescue. It's a humbling reminder that nature still holds the upper hand. Technology never stands still. Engineers are constantly working on new designs and materials to push the boundaries of what helicopters can do. We may see helicopters with even more powerful engines, innovative rotor designs, and autonomous flight capabilities, further extending their reach into the sky. While we strive to conquer the skies, it's crucial to respect the limits of both our technology and the environment. The mountains, especially giants like Everest, demand respect. Pushing the boundaries is part of human nature, but it must be done responsibly, with a healthy dose of caution. The inability of helicopters to reach the summit of Everest is not a defeat, but a challenge. It's a challenge that beckons to the adventurous spirit within us all, urging us to push the boundaries of what we believe is possible. The summit of Everest, standing tall and proud, represents the ultimate test of human ingenuity and determination. It's a testament to the awesome power of nature and a reminder that some places remain unconquerable. The sheer force of the winds, the thinness of the air, and the treacherous terrain all combine to create an environment that is as hostile as it is beautiful. These elements serve as a humbling reminder of our place in the natural world and the respect we must have for it. But that won't stop us from trying. The human spirit is resilient and relentless. Every failed attempt is a lesson learned, a step closer to overcoming the insurmountable. Pilots and engineers work tirelessly, innovating and adapting, driven by the dream of one day conquering the unconquerable. Their determination is a beacon of hope and inspiration for all of us. The spirit of exploration, of pushing the limits of what's possible, is deeply ingrained in us. From the earliest days of human history, we have always sought to explore the unknown, to venture into uncharted territories. This drive has led to some of the greatest discoveries and achievements in human history. And who knows, the future holds endless possibilities. Maybe one day, we'll see a helicopter touching down on the roof of the world. It will be a moment that symbolizes not just a technological triumph, but the enduring spirit of human exploration. Until then, we will continue to dream, to strive, and to push the boundaries of what we believe is possible. The spirit of exploration endures, and it will continue to drive us forward to new heights and new horizons.